So welcome everyone to this video. It's a continuation of the KNN imputer that we have done in the previous session. So just as a prologue of what we have done before, so we have taken a data set, a banking data set, which is having the customer information of prospective subscribers. We are trying to predict whether those subscribers, potential subscribers, will be subscribing for the term deposits. So that's what we are trying to predict. So we had a lot of non-existent or non-filled values in many columns like job, education, and all. So those things we imputed. That means we filled those non-available values like blank values in certain cells using KNN imputation. And then while we did the KNN imputation, instead of applying it for the entire data set of 41,000 odd rows, we just sliced it into 4 parts, and then we created it. We did the KNN imputation, and post doing it, what we did is we just consolidated it into one big data set. And so on that data set, what we have done is we have added to the mainstream data, and then we started uh, with the actual decision tree actually. So this mainstream data is having the D tree. The data frame name is D tree underscore data. So there we are having all the imputed data plus the other data in one single consolidated form actually. And here we are checking the data type, because basically for a decision tree, the Y information basically needs to be categorical. So we are trying to identify whether it's categorical or not. So in fact, what we have done is, in order to change it to categorical in the previous code lines, we have used the for loop, and we have converted the object into categorical actually. So definitely, so if you see here, it was object, and then we applied the for loop and changed data type, and we converted into a categorical variable actually. And then we are also importing a package called as decision tree classifier. So what we are trying to do in this particular session is we are going to use decision tree as a methodology, but however, in addition, we'll also use something called as random forest. So before we understand what is decision tree, so decision tree is a kind of methodology which helps you to deep dive into the data, so and then identify different segments of data uh, actually, and then so those segments we can call them as branches, and within each segments, what are all the sub segments that are available, we call it as leaves. So using this decision tree, we'll be able to identify what are all the different segment of customer base that we are having, customers with different educational information, job information, right? So likewise, so this based on this, the specified branch segments will be created, and based on the branch segment, the sub leaves will be created actually. So this decision tree will help you to classify whether a particular customer with a particular pattern it will be subscribing to the term deposit or not actually. So that is the whole understanding behind this exercise. So what we are doing is, so what we have, as we have seen before, we have downloaded the package, the decision tree package actually. And now what we are trying to do is we are trying to create a data set of only x's, so that so here for that we are dropping the y variable, and we are creating a variable called as x, which is having only the x variables into this, and the y variable we are putting into another variable called as y actually. So after doing it, what we are doing is we are trying to find out whether the x variables are having all the relevant x values. So we have identified here. And if you see it closely, in this particular data set, we have removed p outcome and p days, because in the previous video I showed it that the p days and p outcomes are having too many non-existent values. For example, in p days, there is 999 is a code number we have used for non-existent value, that is a null value, and this is more than 35,000 records or in PDs or 999. That means more than 35,000 records are non-existent. So they are null values. So we have ignored it because we do not have an opportunity to do. I mean, we cannot actually do an imputation here using mean, median, mode, or KNN methods. As well as we cannot do a kind of methodology. We cannot have a methodology we do not have an opportunity, I would say, rather, to go back and do the sampling because this data set is coming from Kaggle actually. The same applies for P outcome also. So we have actually removed these two data fields actually. And so now in X is have X. This is the final X data set, and now we are importing the train, test, and split package, which will help you to split the particular data set X and Y into test and train and test set actually, and we are earmarking the test set to be size to be 30% of the overall actually. And then we are using a method called as entropy method. So there are different types of methods that are used in decision tree classifier. One of the method is Gini method. Another method is entropy method actually. So I mean, entropy method is something that is used regularly. So we are using the entropy method over here, and then what we are doing is here we are fitting the model uh, into a decision tree model actually, and there we are supplying the training X variable and training Y variable. So in the training underscore label, you are having the Y data, and train underscore you are having the X data. Both belongs to the training category set actually. And then we are finding out the model score. The model accuracy is coming out to be 88%, and the I mean, here the test accuracy is coming out to be 88%, and the training accuracy is coming out to be 100%. That shows the model is overfit actually. That means whatever the training is able to bring in, that score it is unable to reproduce during the testing stage actually. So it's a classic case of overfitting. So that means we need to regularize or fine tune this particular model. In order to fine tune this model, we are using certain options. So we are trying to find out whether this model performance will improve by importing something called as bagging method actually. So this bagging method is, I mean, it's a kind of advanced version of the decision tree. But only thing is the bagging method, it will be using something called as bootstrap sampling methodology, wherein, so in this decision tree, what we are doing, we are just creating only one model, right? But however, in a bagging method, we are going to create multiple methods. So in each method, I mean, multiple models will be created. So this, how these models are created. So out of these 40,000 data sets, we are going to generate the first data set, and then further we are going to, and then we are going to replace it. That means imagine we are taking 5,000 samples from there. So the randomly 5,000 samples will be picked from this 40,000 data set that is existing. And then what we are going to do is we are just going to replace this 5,000 again, and then out of the entire thing, again one more 5,000 will be taken up. Likewise, you can go for as many iterations you want. So imagine you are creating a 20 models. So that means you will have 20 bootstrapped samples available. So, and then out of this each sample, the model will be created actually. So as and when the model is getting created, the bias, that means the patterns in the particular data set will be studied, and then the bias will be reduced actually. But however, the variance will keep increasing. Why the variance will keep increasing? Because due to this randomness of smaller data set that we are taking, all the data sets, the patterns will not be captured. So for example, there are 100 patterns available in the entire data set. The first 20 patterns are identified in the first data set. Then the next data set, we may have additional 10 or 15 data sets, samples, I mean patterns identified. So as a result, in each model, the entire patterns are not identified, although certain whatever that is covered, it's well covered actually. So that is the difference between bias and the variance. So So we'll have improved by, we will have low bias due to this method, but the variance will be higher as we are having multiple data sets, and we are taking only a part of the entire data set in each stage actually. But since we are taking a part of the data set in each every time, so if you are going to take it 20 times, that variance, when we keep adding up the first model to the second model to the second model to the third model to the fourth model, the the variance will keep coming down actually. So that is the whole idea behind this actually. So at a singular level, the model will have a better bias, and it will have high variance as the models are added up. Like when more models are added up, like when I say more models, when more iterations are added up, the variance will keep coming down. As a result, it is getting cancelled out each other actually. So this is the method that bagging method is going to use actually. So using this bagging method, we are instantiating the bagging classifier, and we are saying that we are going to have 50 iterations. That means 50 bootstrap samples will be taken with replacement, and every sample will, we are going to have maximum 8 samples have to be taken. In fact, you can also increase it. I will let you know how we will increase it. And then the basically the scores, we wanted to have the scores coming out actually. So we wanted to display the scores, the accuracy scores. That's the reason we have put the OOP score as true. And now we are fitting the model, and once we have fitted the model, we are printing the OOP scores. That gives you the accuracy that we are getting due to this decision tree. Due to this random forest classifier actually. So this bagging classifier, as I said, is also called as random forest. So here what we are trying to do is we are trying to play around with the number of iterations. So previously it was 50, now I have changed it to 100 if you see here. And then the number of maximum samples I have given as 8. Rather I have given it as 7,000 in order to accommodate the right patterns within the data set every time when the iterations are carried out actually. So when I did it in this way, if you see here clearly, the model score has increased to 91%. See, previously it was 88%, and here it has gone up to 99%. So still again, what I am trying to do is, okay, now what we have done, we have tried optimizing the model using random forest, and before optimization we in fact did use the decision tree. So we found that the random forest, which is the bagging classifier, is having a better accuracy rate when compared with the decision tree. But again, we are trying to find out if I regularize or if I fine tune this decision tree model, whether will I be able to improve the score much better than the random forest actually. So again, I'm trying here. Again, I'm giving the I'm creating the model, decision tree model, and then I'm fitting it. Once it is fitted, I'm trying to find out the model score. So the model score is coming to 91.1% in the test, and the training also it is coming on to 91.9. So that means the model is able to replicate the same performance, almost equal performance from between the training and test set in the decision tree. But however, still the accuracy when compared with the random forest is lower actually, because in random forest we are getting 91.4%, but however in the decision tree here we are getting a 91.1% in the test set actually. So one bigger difference between the decision tree and the random forest is that in the decision tree you are going to create only one model. That model will be split into train and test, and then we'll get the accuracy scores, and we'll be comparing whether the performance that we have got in the training is same as is equal to the performance we got in test also. Both should be equal. If the test is coming out to be lower when compared to your training, then that means your model is a kind of overfit one actually, right? And if in case But however, in case of your random forest, we will not have. In random forest, we are going to use a bootstrap model, where in the bootstrap sampling methodology, we are going to in the bagging methodology, what the it will be using a bootstrap method. So in the bootstrap sampling method, we are going to have the entire sample set, and within the sample set, we are going to have. I mean, we are going to randomly pick the certain amount of sample. As I said before, here we are saying we'll pick 7,000 samples. So 7,000 samples will be taken up first, and then again the entire sample set will be put together. Then the second iteration will be created. Then the third iteration. Likewise, here I have given 100 times. So how many iterations I have given, that many iterations will be created. But there won't be any test and train and test data set that will be coming out. Actually, each will be a model by itself. Each iteration will be a model by itself. But when we combine together the entire model, what happens is the amount of variance which is higher as a single model will be cancelled out when they are collected consolidated together. Actually, that is a big concept behind the random forest methodology. Actually, so comparatively here, what we have identified is the random forest is giving you a better score when compared with your decision tree. So this is the learning that we have identified. So we'll go ahead and use the decision tree. I mean, we'll go ahead and use the random forest classifier in our future methods for this particular data. Actually, so as a continuation of this, in the next video, what we will be discussing is we'll be discussing exactly how to identify what are the actual values versus the predicted value, right? So that we will be identifying, because here we just saw the accuracy, that's not enough. So we need to show the actual predictions also, the classifications also, right? So that needs to be identified. So that I'll be showing it in the forthcoming session actually. So hope you got an idea about decision tree and random forest using bagging methods. Any questions, please let me know. You can always comment and let me know. I will be able to guide you on that actually. So thank you so much.